Hello, welcome back everybody. Today we will be talking about sets notation in geometry. This is pretty much the very first, video for our geometry class. Sit back, relax, and grab a popcorn and grab a drink while you're at it, okay? To begin with, let me go ahead and define a few things. Set notations, we have a few definitions to start with, okay? So the very first one is that, what is a set? A set is, in short, a group of things. So you can have, say, anything that is grouped together, you can go ahead and call that a set. Now, to be a little bit more specific, the element, that's the next keyword, is the things that are inside the set that we're talking about. So, for example, if your set consists of, say, a key, a phone, and a car, then those three items would be considered the elements of the set, okay? Now, the last one is going to be called a subset. And in short, that means that you have a set within a set. All elements inside a subset must be in the main set. So going back to our example, if we have, say, a key, a car, and also a phone, one subset would be just the keys, or another subset would be just the phones, or another subset would be the keys and the phone, or maybe even the keys, the phone, and also the car. So it could be just any number of things that are inside the sets. Okay, so here is an example of what we're talking about. Example number one. Let set A be the alphabet. So you can see underneath right here, I kind of drew out what set A is. A, B, C, D, all the way to X, Y, and Z. Let B be another set. And in this case, we're going to go ahead and say that it's the set of all the vowels. And we're not going to include Y because, Y is kind of like that special case that just kind of sits out there that sometimes it belongs, sometimes it doesn't belong. We're just going to say it's not going to belong in this case. So in short, B is just A, E, I, O, U. Then what I want to do is say the relationship between the two. Then one conclusion in this case is that set B is a subset of set A, because you can see that all of the elements inside set B is contained in set A. And the notation that we can use is the following. You have B, and then you have this little weird symbol right there, kind of like almost less than or equal to A, like so. So then that way is, that's basically our notation for a subset then, okay? So best way to remember it is literally, it's like a less than or equal to sign, because it could be anything that's inside of set A so long as it's inside set A. Another example of this is, let's say S, the set, is going to be all the whole numbers. And I wrote out all the whole numbers underneath. Well, not all of it, but, just get an idea. What I want you to do is name some possible subsets of S. So if you want to try to give that a shot, go ahead and do so. But if, pause the video if you want to. But then if not, then I'm going to go ahead and give something. So for example, maybe I can say the set of all the odd numbers. So we can say that odd numbers would then be a subset of S. What's another one? Maybe just the even numbers, okay? That would be a subset of S. Let's get a little bit fancier. Maybe let's say the prime numbers, right? Those can also be the subset of S. And let's take one more, maybe even just the number 2, right? That right there, just the number 2, is also considered a subset of S. So remember, subset, so long as you have any number of elements in there, including 0, or including 1 or 5 or whatever, it's a subset then, okay? So moving on, some quick questions that we might want to answer about this just to see if you can understand how it works. Part A, is the multiples of 6 a subset of the multiples of 3? The answer is yes, because all the multiples of 6 are inside the multiples of 3. So yeah, that one is true. So that one is a yes. Let's see, prime numbers, is that a subset of odd numbers? This one you got to be careful about. The answer is actually no, because the counterexample is the number 2, right? Number 2 is not an odd number, okay? So the answer is no in this case. Anytime the answer is no in geometry, the best way to justify your answer is to give a counterexample. So this right here is my counter example. And you'll notice that the notation that I use is this little weird E thing right here. So this, again, the symbol this means that it's an element of the set, but if I put a dash through it, then that means it's not an element of the set. So right there, you can see that my counterexample is that 2 is not an element that's inside the set. And this little bracket thing, that's the set notation. So that's one way you can tell that we're talking about a set then. And finally, for the last one, if A is supposed to be the set 1, 2, 3, 4, 5, is 1 a element of the set A? The answer is yes, because we are, the number itself is going to be in there then, okay? Now here, there are two notations that you have to kind of be careful about. The first one over here, this is saying that 1 is an element inside A. Okay, repeat it one more time. 1 is an element that's inside A. It's one of those things that are inside the set. Whereas this right here, 1 is also a subset of A because, again, remember, 1 by itself could be considered a subset, a set within a set of A. Okay, so please be very careful about the notation. This is an element of, meaning that it's it's something that's inside a set. Whereas this is kind of like saying a subset, a set within a set that's also a set itself. Kind of strange, isn't it? Okay, hopefully you'll know the difference then. All right, keep going then for a little bit. Okay, another definition that you should know is called the empty set. The empty set here is defined as a set without any elements, and it is denoted by this weird looking little symbol over here. Now, I want you to be very careful about this one also. This symbol is not the same thing as the number 0, okay? So this is not the same thing as saying 0, because the empty set is simply saying that there are no elements in there. 0 could potentially be actually a set then, inside like some other set numbers. So anyhow, here are some examples of an empty set that we're talking about. So here, the first one, let's say that set B is the set of all pink elephants that are in the room. Well, currently, I don't see any pink elephants in my room, and hopefully there aren't any in your room as well. So that right there, to me, is going to be an empty set, okay? Whereas set T over here, here's another example. Set T is going to be the set of all, it's going to be all the students under the age of 10 in our class. And seeing that most of you guys are probably at least the age of 13, maybe 12 in some cases, I don't know. Some of you guys are a little bit smarter than me when I was your age. Then there's pretty much nobody that's going to be in that category. So that would be also considered an empty set. So each one of these we can denote it as the null set or the empty set. That's basically how we would write it then. Okay. Now here's a quick question, or some quick questions about this. Can a subset be the entire set? So that means that if I have a set, then could the entire set be considered a subset? The answer is yes, because remember, a subset is any number of elements of the original sets. So since it could be any number, then that number could be just however many that you have to begin with. Okay, so the answer is yes for that one. Next one, part B. Is the empty set considered a subset? So empty set right here, is that considered a subset right there? And the answer is also yes, because remember, any number of elements inside the original set. Well, 0 is a number, right? Because if you have 0 elements, well, that's a number that we can consider according to our definition. So the answer is going to be yes then. Well, now with those two in mind, then what is the minimum number of sets inside any set? Well, that one's a little bit tricky, but according to part B, the answer is going to be 1. And the reason is, well, what if your original set is the empty set to begin with? Then that means the subset is going to be just itself. So therefore, the answer is going to be 1 in this case. Okay? All right. Let's see. Keep going over here. A few more things, and then I think that's it. So last few things are the definitions over here once again. We have two terminologies right here that you need to get used to. The first one is called union, which is denoted by that U shape. That's like just literally a U shape then. And that is represented as the set of all elements in both sets, or actually 2 or more sets. So here in the blue, you can kind of see the notation for it. So if you have like say an element that's called X, X is in either A or it's in either B. Whereas the next definition, we're looking for the intersection, denoted as kind of like the upside down U, the set of all elements in common in two or more sets. So that's denoted as element of X is in A, and at the same time, it has to be in B. Now, if I were to draw this as kind of like a diagram so you can kind of see how this works, let me just kind of, draw it on the side over here. Let's say that this is the set of all the elements that's in A. So this right here, let's say that's all the element that's in B. So if I'm looking at union of A and B, then that means it's everything that they have in common. It's all of these guys right here. So that would be the union then. Now, going by the same example, let's say that A is over here, and then it overlaps with B that's over here. The intersection that they have in common is just this small little wedge right here. So that's going to be the intersection. And it goes to show you, sometimes the intersection, well, they might not have anything in common. So we'll take a look at some of those examples then. Okay. So underneath, once again, there are some examples of this. So here, let A be the multiples of 3. Let B be the even numbers. And let C be the odd numbers. So what I want to solve for underneath is, well, what is A union B, A intersection B, and last one, B intersection C. Starting with the first one, A union B. Well, that's looking at what they both have together. So all the numbers that they have together, that's going to be in the set. So starting from the very beginning, you see 2, you see 4, you see, kind of missed that one. Well, let me go ahead and put that in. We missed the 3. You don't actually have to put them in order, but it's nice too. Let's see, you see the 4. Now, here's a tricky part. There's a 6 in A and there's a 6 in B, but we don't want to rewrite it twice. So we just go ahead and write 6 once then, okay? You can't double count, or you shouldn't double count any elements then. Let's see, keep going. We also have 8, we also have 9, we also have 12, and so on and so on and so on. So all of those that they have in common, that's going to be A union B. Next one is going to be looking for the intersection, what they have, not joined together, but what they have in common then. Well, since A is going to be the multiples of 3 and B is going to be the multiples of 2, then I guess by LCM, lowest common multiple, then we're looking for what they have in common, which we said earlier is the multiples of 6. So you can see over here that 6 is what they have in common right there. So that's going to go down here as the first one. The next one after that is probably going to be 12. So it's going to be 12 right here. 6, then it's 18, then it's 24, and so on and so on and so on. So you can literally just write out all the multiples of 4, or you can just say the multiples of 4. Okay, sorry, not multiples of 4, multiples of 6. I apologize for that small little error. Okay, so get rid of that part and change it so that it says multiple of 6. But whereas unfortunately in A union B, there's really kind of like no way of saying the combination of multiples of 3 and multiples of 2 as simply as we could for multiple of 6. So you just have to kind of write it out. And this very last one over here, we're looking for B intersection C, meaning what does the set B and set C have in common? And, well, since one is odd numbers, the other one's even numbers, I don't see that they have anything in common. So that means the intersection is going to be the empty set then. All right, so I think that should do it. Thank you for watching.